All right, guys. Thanks for joining me today. I'm going to be talking about ways to improve your code. The tagline I gave it is "Be better by building better." My name is Ankur. Hope you guys know me by now. I've been the one kind of lurking in your Slack channels and dropping in on your Zoom lectures. So if you don't know me, hi. Again, thanks for joining me today. So yeah, let's get started.
Hey, Ankur, there's like a lot of background noise or something. Does anybody else hear that?
I think it might be my laptop.
Yeah, I hear it too.
Might be my laptop fan.
Yeah, it's like it almost sounds like ruffling in the microphone. No, did you hear that?
All right, so let's jump into the presentation. All right, so just to give you guys an overview of the topics I'm going to talk about. Generally, just three basic things. One, I wanted to share some advice about interviewing. I know all of you guys are going to be interviewing next week. Some of you guys will be doing some coding challenges this week for interviews. So I know that's maybe something new to some of you guys. Others may have been well practiced for this. So, but yeah, I just want to offer my advice just from what I've gone through with interviews and hopefully be helpful for you guys. After that, I thought it'd be beneficial for us to do a practice coding challenge. I know we've done this before throughout the cohort. It never hurts to have more practice, especially closer to interviewing dates. And then after that, the bulk of this presentation is going to be focused on discussing ways that we can improve our code. So this is a key skill that you need as a software developer to succeed in the industry, and also is very helpful when you're doing coding challenges for interviews to have that extra step of finding ways to not only solve the problem, but solve it in a better manner. Definitely can decide if you get the job or not when you're competing with other folks. So yeah, that's just overview. Let's get to the first topic. So the first topic is Ankur's advice on acing assessments. Can help pass up that alliteration opportunity. But two general buckets here. One obviously is what you do ahead of time, how you prepare. And the other is how you can succeed during the interview. So preparation. Again, I know a lot of this is general information. Probably heard a lot of this before. I know James and Kelsey had a series of lectures on interview prep earlier this week, and they did a great job. So hopefully none of this is new information, but I kind of want to just go over the key points that I think help for preparation. And the first is connecting with your HR contact or whoever you set up your interview for you, and ask questions about the interview ahead of time. A lot of these questions might seem obvious, or you could maybe assume them, but it's always good to be sure about what you're going to step into for the interview. So question number one should be, what type of interview should you expect? Will it be behavioral? Will it be about your background? Will it be about technical aspects? You don't want to spend most of your time working on technical interviews and then step into the interview room and realize that it's 90% behavioral, right? You're not going to be allocating your prep time accordingly if you just don't know what's going to be covered. For technical interviews, I always ask what programming languages will be covered, or can I use for technical challenges. Again, you don't want to assume stuff here. You might see on the job description that one of the languages they require is Python, for example, but you can't automatically assume that the coding challenge will be in Python. You want to make sure, like if they say, you got to use JavaScript or maybe like C++ or some other language that you're less familiar with, you want to have that time ahead of time to kind of brush up on that language and be prepared for the technical interview. Also worthwhile asking what topics might be covered, right? So software development has so much to it. There's so many questions that one can ask. It's great if you can kind of narrow it down. Like if they say we're going to be asking networking questions, or maybe client server architecture questions. It's just good to have that narrowed focus so you can allocate your preparation time to where it matters. And finally, it might seem kind of obvious, but it's great to ask what they recommend. They might be able to give you resources or give you, again, general guidelines like, here's some coding problems that we think are good practice, or again, they might just give you a direction where you can focus your time. And that, again, narrows down your search and can make you better focus on the things that will be on the interview. So again, definitely make use of your HR contacts or whoever set up the interview, and get that communication going before the interview instead of right before the interview starts. The next thing, again, probably fairly obvious, but always get some practice in. Just do a coding problem or two before the day before your interview, just to get your mind kind of fresh and kind of get that creative, I guess, analytical side going with some practice problems. Google is our friend. We all use it probably in our daily lives. It's great to just kind of look up what interview questions are asked for your type of job. Again, maybe if you're a front-end developer or a database administrator, like it's good to kind of just know what types of questions or what maybe specific questions are popularly asked during an interview. And also, yeah, do problems on HackerRank, CoderByte, LeetCode. Again, there's a lot of great resources on the internet that we can make use of. HackerRank and CoderByte, I've had interviews on there from companies. So in addition to just doing problems, I highly recommend just getting familiar with those sites if you've not used them before. Again, kind of just remove the surprise elements during the interview. If you can kind of get familiar with the UI and understand how to use those sites ahead of time, just they're not too complicated, but again, it's good just to have that out of the way ahead of time. The final, maybe most important advice I could give is relax. I think this is probably the easiest to overlook. I know interviews can be stressful. You guys want to do well, but don't forget to give yourself a break, especially like your mind doesn't want to be doing coding problems for 10 hours straight and then jump right into an interview. Like I recommend getting a good night's sleep. Definitely get 7 or 8 hours if you can. I would definitely recommend that over staying up all night and kind of just trying to cram everything in and then hoping your mind's ready by interview day. So yeah, those are my general tips for preparation. Let's jump into the interview day. So I have a bunch of steps.
Hey, Ankur.
Yep.
Are the slides supposed to be updating through this, or are we still staying on the title page?
Oh, are they not updating? Thank you for pointing it out. Let me see. Apologies there. Thanks for mentioning that. Do you guys see the title screen right now?
Now we see the second one.
Ankur's advice on acing assessments.
Gotcha. Sorry about that. Technical difficulties. I apologize. So let me just back up for the previous slide. So as I talked about, just questions you can ask, getting some practice, and relaxing before your interview. Sorry about that, guys. All right, so jumping into advice on acing assessments during the interview. So a bunch of steps listed here. You guys probably have heard a lot of this, so hopefully it's not new information. But the first thing I recommend, again, take a deep breath. The key here is relaxing. Again, interviews can be stressful. They can be overwhelming, but the key thing is not to panic for an interview. When you're handed a technical challenge, the worst thing you could do, I think, is panic and kind of get your mind racing, like, oh no, I don't know this. I don't have time to do this. So yeah, first thing would be take a deep breath. Next thing would be don't rush into the problem. Kind of take maybe a minute or two to digest the technical problem that they've handed to you. Again, this could be just a coding challenge online, or if you're in person, just take a couple minutes, formulate your thoughts, and kind of get a game plan going mentally. I would kind of compare this to like if you're gonna cook something, you don't really just jump into the kitchen, throw a bunch of ingredients into a pot, and just go from there, right? You want to kind of think about what ingredients do I need? How do I need to prep this stuff? Do I need to chop the onions? Do I need to boil water? Kind of get your bearings straight in terms of what you're going to need to use for the task at hand, whether it be cooking or doing a technical challenge, right? So after you have a couple minutes to digest, again, there's nothing wrong with, if you're in person saying, hey, I need a couple minutes, kind of just think quietly. Your interviewers are going to understand that you're trying to come up with a thought process here. And then during that time also, take time to ask some questions. I actually always try to force myself to ask a question, even if I think I understand the technical problem like 100%. I always want to just make sure I'm asking some question, A, to get a dialogue going, and B, to ensure that I understand the problem, and also allow the interviewers to make sure that I understand the problem also, make sure we're on the same page. Again, you don't want to assume something if you think like, oh, okay, I know what's going on here, but you get it wrong, right? That's probably the worst case if you just start coding and realize you missed the key requirement, for example. Like a typical question you could ask here is like, are all the inputs going to be valid? Because do I have to do error handling or error checking? Usually you don't have to do those things for coding challenges, but that's not 100% the case all the time. So always make sure any assumptions you're taking as you start the problem, make sure that you confirm that you can take those assumptions, or confirm that you can't take certain assumptions. The third point here, again, you've probably heard this repeatedly, and I'm just going to kind of reiterate this. Talk during an interview. You want to share what you're thinking. As an interviewer, I've been outside. It's difficult when you have a candidate who kind of just like may know what they're doing, but they're not really sharing, how they're thinking about the problem and what they're coding up. So it's kind of your opportunity to share how you think about stuff, how you process things, and again, it helps the communication flow during an interview rather than you just, putting your head down, working for 30 minutes, and then handing in a problem, right? So communication is key. You've heard this before, and I'm going to reiterate it there. So again, all this stuff is generally, even before you start writing code, to take these steps and ensure that you know what you're going to be doing for the next whatever hour, 2 hours, whatever the time limit is for the challenge. Continuing on with the coding challenge, step number 4 here is going to be the bulk of your time, right? You're going to be handed a problem. You got to get to the finish line. Always try to get to the working solution first. Don't get bogged down on trying to create the perfect solution or trying to figure out, ways to reorganize your code. If you have an idea that you think will work, obviously, if you're way off ahead of time, that's when you bring it up to the interviewers and they'll kind of guide you if they think your game plan is off. But otherwise, kind of just attack the problem and get it to a working solution. Because having any working solution by the end of the interview time is better than having no solution at all. I think that's kind of obvious, but sometimes I've definitely seen candidates kind of stress out about minor details ahead of time, rather than kind of just focusing on tackling the problem overall. So once you do finish and get a working solution, definitely good to test your working solution, even with just minor tests. This is twofold. One, obviously, is to make sure that your solution works. I've definitely had cases where I've coded up stuff, just like if I'm doing a coding challenge on my own, and I feel like I did it right, I think it works, but then you kind of test it and see maybe an edge case and get handled, or maybe you just kind of missed something that was kind of obvious. The second reason I would say to do this is you want to show the interviewers that you are mindful of testing, right? Testing is very important for during software development. We've talked about test-driven development throughout the cohort. So just even doing a trivial test case in front of your interviews, if it's live, or if it's a coding challenge on screen, maybe writing a small test case when you submit your code, if that's allowed, kind of shows that you're actually thinking about testing. You're not just handing in work without verifying it. Next point would be adding improvements. So this is only if you have time for it, right? Sometimes these technical challenges can be really grueling, and you just have barely enough time to get a working solution. That's definitely possible. That's happened to me a lot. But if you do find that you finish with time to spare, use that time wisely. And I would say look for ways to improve your solution. Again, this is something that will show your interviewers that you're capable of critical thinking, that you don't just settle for the first solution you get. You're able to kind of think on the next level and say, all right, I got a working solution, but there probably can be improvements made here. Let's see if I can make any. And then if you don't have time to do it, and again, this is for if you're in in a live interview session, whether online or in person, at least talk about what improvements you want to make. It's good to kind of, again, be mindful about, not just settling for what you have right now, but what could be done better. Analyzing your solution is something that you guys are probably going to be asked during an interview. As I have a hint there, big O questions are very common. I know we had a lecture on that, probably in week 2 or 3 of the cohort. Definitely brush up on that before interviews, because you're most likely going to be asked about time complexity of your algorithm, or memory complexity. They're very common, so don't be surprised if an interviewer asks about this. And the final thing, I guess once the assessment is complete, again, if you're talking with someone live, or even if it's like a coding challenge that you submit and you have an HR contact, I like to kind of email the contact, or if it's in person, ask about the solution, kind of get their feedback, see what they were looking for. Regardless if I got a working solution or not, like I want to know, again, how I could have done this better. Obviously, the interviewers that you're talking with are going to have a lot more knowledge about the problem at hand. So it's great to kind of just ask that question. Again, one, for your knowledge, but again, you're also trying to show your skills, I guess, skill sets. And one of those should be that you're eager to learn new things. You just don't assume that you know the right way to do something. It's always good to get that input and show that you're willing to improve your solutions. So I know those are a lot of steps. Again, I'm sure you guys have heard a lot of these things before, so hopefully nothing surprising there. I'm going to pause here in case there's any questions about any of the tips I provided, but hopefully you guys are pros about preparing for interviews and going through it. So any questions on just some interviewing tips that I've shared here? All right, I got a thumbs up for Tommy. I think everyone seems pretty good. Jared, do you have anything?
Yeah, on testing your code, how much do you need to know, or would you want to know about like writing out actual like test files versus just like having just simple like print statements and like expected output?
Great question. Yeah, I think especially for these coding challenges, your time is going to be really condensed. So writing like a whole test suite is probably not going to be something you're going to have time for. So yeah, I think it's more of the latter that you mentioned. Yeah, kind of just write, good comments, good, like, yeah, print out statements and just say, hey, like, if I input 2 here, I expect the output to be like 4. Even in comments, just it shows that, you mentally went through a test case or 2 and verified your solution in some manner, right? So yeah, anything you could do to kind of convey that with a technical challenge, especially if you're not talking with a person live, yeah, try to sneak that in there if you have time for it. Yeah, thanks for asking that question. All right, I think we're good here. You guys have covered this stuff before, probably. All right, let's go to a real coding challenge. So again, you guys are going to be doing a lot of interviews in the near term, so I thought doing a coding challenge would be beneficial. I know a lot of you guys have done this throughout the cohort. Always good to get that practice in. So I have a coding challenge for you guys. I'm gonna give that to you right now. So kind of read over this question. I'm going to give you guys some time to process it and then handle any questions. And then after that couple minutes, I'm going to ask for a brave volunteer. So hopefully someone's ready to kind of code. It's going to be pair coding. Don't worry, it's not going to be too difficult. I'm going to be coding with you. So our task at hand here is, given a positive integer n, return the largest numeric palindrome, if one exists, that can be produced by multiplying 2 n-digit numbers, or just return 0 if no palindrome exists. So I'm going to give you guys a few seconds there, just kind of digest that, think about it, formulate thoughts how you might attack this problem, and then if you guys have any questions about the problem, obviously we'll go over those too. All right. Hopefully you guys had a chance to digest that, and yeah, let me know. Does anyone have any questions? Does the problem make sense? What it's asking for? Anything?
I have a question, Ankur. 2 n-digit numbers. Are 2 n-digit numbers the same as the input, which is n?
Yep. Yeah. Okay. Good question. Good to verify that. So yes, your input is going to be an integer value of n. So for example, if your n value is 2, you're going to be multiplying, let's say your n value is 3. You're going to be multiplying 2 3-digit numbers together and trying to find a palindrome that way. So yes, n is the length of your number, not what numbers you're going to be multiplying. Does that make sense? All right. If there's no more questions, we could jump right into it. So let me pull up the code on screen here. Sorry, give me a moment. My window seems to have disappeared. Are there any other questions on, I guess, what the technical challenge is asking for? Do you guys kind of have a game plan in mind?
Yeah, I'm sorry. Could you give the example again?
Sure. So let's say we give you an input value of 3 for n. We're going to want to go over every 3-digit number and multiply it by every other 3-digit number. So again, if n equals 3, we want to multiply like 553 by 367, for example, because both of those are 3-digit numbers. We want to multiply those together, and then the result of that, we want to check if the result product is a palindrome or not. All right, let's go right here. Can you guys see my coding window?
Yep.
All right, great. I just want to make sure I don't have any more technical difficulties. All right, so again, we have the problem listed up top. I'm going to ask for a brave volunteer at this point. Again, I'm going to work with you. We're going to do a lot of pseudocoding. Again, we're just trying to get a working solution here, so I promise it won't be too difficult. You guys going to make me pick someone?
I don't mind going, but it's gonna take us a long time if you pick me. I'm just gonna throw it out there right now.
No, I love the initiative. Or I'm going to work with you. So,
All right, let's do it. Let's do it.
All right, great, Tommy. Thanks. All right, so I'm going to be coding on screen here. I'm going to be asking you kind of to guide me, and then we'll go from there. Right. So, I guess what's the first thing that we all recommend when we're tackling a technical challenge after we thought about it and kind of are ready to start coding?
Are you like pseudocode?
Absolutely, yeah. So I'm a huge fan of this. I always want to, transfer my game plan from my head onto the screen to make sure I know how I'm going to type this up. So yeah, let's pseudocode this, Tommy. What do you think? What are some steps we're going to need to solve this problem?
Okay, so given the positive integer value n, return the largest numeric palindrome if one exists that can be produced by multiplying 2 n-digit numbers. Else return 0 if one doesn't exist. Example, n equals 2. Okay. Okay, so we have our input, and so n is equivalent to the number. N is equivalent to the number of the amount of numbers in the integer, or the amount of digits in the integer, more specifically. And then I'm really bad at math, but I think that my first inclination would be to go would be to take n and instantiate a range with it. Mm-hmm. Sorry, I should probably speak like I'm pseudocoding.
No, you're good.
So,
you're good.
Okay, I'm just thinking out loud right now. So we need to instantiate a range, but to instantiate the range, like, so say the input is 10, we would want to find the input is 10, therefore 2 digits, and we want to find the largest value of 2 digits, which would be 99. Right? Is that the right thinking?
Almost. So I think there's still maybe a bit of confusion with what n is. So you said if n equals 10.
Yeah, if n were to equal 10, let's see, given a positive integer value n, return the largest numeric palindrome.
So n here is actually the number of digits that will be in our the numbers that we're multiplying. So for example, let me go over an example here. So if n equals, let's say n equals 4, that means that our numbers are going to be formatted like that, and we're multiplying
Oh, sorry. Okay. Sorry, I was thinking about the totally wrong way.
Yeah, no, it's definitely not your common input. Like instead of giving you the actual value, we're giving you, I guess, a concept of the values.
Okay. Okay.
So yeah, if n equals 4, we're gonna have two 4-digit numbers, and we're gonna get some product, and then we don't want to check if that is a numeric palindrome.
Okay, so in that case, if so we'd want to do I wish there was a more dynamic way to do this, but I'm thinking like if n equals 1, then our range would be 1 through 9.
Yep. Absolutely.
If n equals 2, our range would be 10 to 99. And we'll just go, I think we could just go up to 1,000 just for the sake of this code. There's probably a better way to do it though. So you have n equals 2, then we would instantiate a range for 10 to 99. N equals 3, 100 to 999.
Yep, you get it. So
Okay.
you get the process of coming up with the range, but we want to generalize this for any n value. So can you figure out can we figure out a way to compute the range that we need based on the value of n?
Yes. So okay, so
Again, so I guess that's probably my fault for asking that question. Yeah, at this point, we just wanted a high level of the steps we're going to take, right? So that's more implementation details. So I just put in a pseudocode comment here, compute the range of values, right? I guess we can figure that out after that. So let's assume we get our range of values. What's the next thing we want to do?
Okay, so we've found our range of values. Okay.
That's right. I mean, we're working together here. So
yeah.
We have our range. So now we turned n, our input n, into, I guess, the values that we actually care about, right? Which are, let's say n equals 1. That's the simplest case. So let's just do that. Our range is 1 through 9. Now that we know what our range is going to be, what's the next step of our problem?
The next step of our problem is to find, to start multiplying to find a palindrome.
Yep. So we're going to need to multiply all the values in our ranges. So what's, I guess, yeah, let's just write that into our pseudocode. Multiply all the values in our
so if the input is 1, then we're just going to multiply all the values in 1 through 9.
Yep.
Okay. But do we have to? Go ahead.
I was going to say, yeah, we're going to multiply all those values by all the same values. So like we're going to cover the whole range of 1 times 1, 2 times 2, 2 times 3, 2 times 7. Go through all the single digit combinations.
Oh geez, that's gonna take a while. Okay.
Absolutely. You get the I guess kind of the conception.
Okay.
It's gonna be gonna, I guess, grow large very quickly with large values of n.
Okay. So multiply all the values going through the range of values. And then we gotta compare that. After we multiply it, we gotta compare it with we have to review to see if it's a palindrome. So by doing that, we have to take the product and check to see if it's a palindrome. And by that, I would just there's a lot of ways you could do that. We could convert it to a string and reverse it and match it, or we could convert it to a list, reverse it and match it.
All right. Yeah, I'm glad you're thinking about these things.
Yeah.
Again, it's good to have that game plan in mind. But yeah, let's just wrap up, I guess, our pseudocoding, and then we could kind of get to the implementation.
Yeah. Okay.
All right, so
And then if it is a palindrome, then we're going to return the palindrome. If it's else, we'll return 0.
all right. All right, that sounds like a good general game plan. I do want to ask about your last step there. So if it is, were you suggesting if we find a palindrome, we return it, or is there anything else additional we need to do?
So I just read that note. Assume all inputs are valid. So all inputs are going to be less than 8 and greater than 0.
Yeah.
Oh,
so
that makes
value
it.
of n,
Okay,
value
I
of
didn't read
n
that.
will
I was
be-
like,
yeah,
all right, if we get any big inputs, like it might not be like possible.
right. Yeah. So
Um,
value of n will be a reasonable value. Again, as you pointed out earlier, this problem is going to explode in, I guess, like complexity, because
Mhm.
if we have n equals 4, for example, we're multiplying 4-digit numbers by 4-digit numbers, and there's a whole range of those. So it's going to take a lot of time, and we're producing large values here. So yeah, again, that's one of those questions that could be asked before we start coding. When you read the problem, you want to ask like, okay, I think this is going to produce really large values. You want to ask, make sure that you don't have to error check for that, for example. But yeah, so our values will be reasonable and will be less than 8 for sure. We want to make sure that our computer can compute the values we're going to be doing. But yeah, going to the last step here. Do we want to return any palindrome we find, or is there a specific one that we need to find here?
The greatest palindrome. Sorry, the greatest palindrome. Yeah.
So if it's a palindrome, what?
If it's a palindrome, I would just append it to a list, and then just take that list and just say, if it's a palindrome, throw it on the list. And then to return the greatest palindrome, we'll just take max of the list.
Yep. Okay, that sounds totally doable to me. All right, so I'm gonna kind of start coding here, and then if you see any issues that we come up with, I might ask you for some implementation details, but I definitely want to code with you here. So I'm going to create a function that's going to do our main job here. I'm going to call it get largest palindrome type. That's going to take an input value of n as the requirements say. And then, so I guess from our game plan, we're going to have some lists. Let's call it lists pals. Just keep it short. And that's going to be a list. And then we want to find the max. And then we want to return that value.
Mm-hmm.
So max. Okay. So let me code up this. So what kind of structures do you think we'll need to use for step number 3? I guess that's step number 2.
But all the values going through our range of values. Okay, so let me think. My first inclination would be to use a for loop.
Yep.
However, for loop. Yeah, for loop would be the best option.
Yep. Again, a lot of times you kind of just go with your gut. And there might be a better option. There might not be. You kind of want to make sure you get to that working solution. So for loop totally sounds reasonable to me. Again, we have a range of values. We know we need to go through them all. So we'll go through that. So let's call it I equals
0.
One value. Yeah. All right, 0. And then I less than. All right, so this is where step 2 comes into play. How can we compute this range? So let's kind of work through it just with a simple example. If n equals 2, we know that the highest value you want to get to is 999, right? So effectively, we just want to stop right before we get to 100. So how can we convert a value of 2 and then produce, 100 being our upper range that we want to stop right before?
Okay, yeah, so all of our inputs are going to be, let's see, so n is less than, since all of our inputs are going to be 1 digit, assume all inputs are valid, less than, okay, yeah, so all of our inputs are going to be 1 digit, so we could just say less than 8. Well, it says all inputs, or less, we could just say less than 8, couldn't we?
Not quite. So again, I know this is kind of confusing, but so n is actually the length of digits that we're dealing with, right? So it's not.
Oh, okay. No. Okay. Sorry. No more than 8 digits. Okay.
Well, maybe I'm misunderstanding. So if we did do n here,
Mm-hmm.
I guess what is this for loop going to be doing for us?
So this for loop is gonna yeah, this the for loop would stop iterating at 7 digits.
So what is this for loop going to do for us here? As in, like, what do we want to achieve?
What are we going to use it for? So yeah, we're going to use this to iterate through the range of values that fit inside n, and we're going to multiply each value. Well, we'll multiply. I got to think about this. Hold on. Sorry.
That's fine. I definitely want to help you out here. So let's get to step 2 here. So we want to find out how to create our range from our input of n, right? So in our case where n equals 2, our range is 10 to 99, right? So if I'm thinking about this, if I have n equals 2, sorry, I'll write that in comments, n equals 2, I know like the highest value I want to get to is going to be 99, which is just short of 100. So if I think about that, if I do 2 to the n, right, I think that'll give me 100, right? So if n equals 2 here, 10 here. So if I have 10 to the second power, it's going to give me 100, right, I think. So if that tells me my upper range, I need to get right up to 100. And then if I want to find my lower range, I think I could do something like 10 to the n minus 1 power. So let's just test this out, make sure this will produce the correct range. So let's say I have n equals 3. So if I take 10 cubed, that's going to give me 1,000 for n equals 3. And then if n equals 3, n squared here will be 100, right? So looking at my input of 3, I have my starting value being 100, which is a 3-digit number. And then my stopping value should be right under 1,000, which would be 999. Does that make sense?
Yeah, that makes perfect sense. Yeah.
I want to make sure everyone's following along. So I think these two, I guess, computations will give me my range. So let's just say I'm going to write my for loop for these ranges. So if you guys remember the syntax for taking a power in JavaScript, you just do this double multiply thing. So that means to the power. So here I'll do n minus 1. And here I'll just do 10. Oops. So I believe this should give me what I need here. And obviously, it's always good to kind of test in between, make sure I don't get too ahead of myself. So I'm just going to log that out. All right. So let me just give this a quick run. Let's see what we get out here. And I get an error. That's not good. I remember my function keyword. And obviously the value of n. So let's just say get largest palindrome. I'm going to use n equals 2. I'm just going to keep this range kind of short. All right, so that was kind of quick, but as you can see, we printed out all of our values. So I think our for loop that we have is going over the correct range. I guess I could scroll up, see where it starts. All right, we're starting at 10, great. And then we're going through 99. So I think we have the correct ranges set, and now we just need to continue on, I guess, with our next thing. So the next challenge is multiply all the values going through the range and finding a product from it, right? So if I think about that, I'm going to need to multiply all the numbers in the range by all the other numbers in the range. Again, they could be the same number, like if you multiply 12 times 12, that's still a valid test case. So in this case, I think I'm going to need a nested for loop here. So let me write that in here. Again, definitely stop me if there's any questions about what I'm typing. But right now I'm just going to create a second for loop that's nested. And this is going to help me get the second multiplying value that I need. So let's go 10 raised to the n. This is my value is called j in this for loop. And all right, so I think I have my two for loops. Of course, I gotta type a little better here. All right, so I have my nested for loop, and now I'm gonna want to, what's the next thing I need to do? I think I need to check if the product is a palindrome. So obviously I'm gonna need to compute a product value, so that's gonna be I times j here. So again, outer loop is using the value of I, inner loop is j. So those are gonna be our n-digit numbers, and n equals 2. Again, we're gonna be going from 10 to 99 with these loops. So let's say I get that product. Just store that.
Shouldn't I and j be offset by one by the value of 1?
What do you mean by that?
Or maybe I'm confused. Because right now isn't so I and j. Let's see. Yeah, because right now I and j would be multiplying. So if I and j right now I and j are the same numbers. Is that right? Am I reading that right?
So the outer loop is going to start at 10, and then the inner loop will be multiplying 10 by every number between 10 and 99. And then next loop for I will be I equals 11, and then 11 wants to be multiplied by all the values in.
Okay.
Okay.
Got it.
All right, cool. No, I'm glad you're asking questions. Always good habit to get into when you're coding up the solutions, especially if you have a live person to talk to during your interview. So I'm going to create a product by multiplying I times j. Then I need to check if that's a palindrome. So this is where I recommend like stubbing functions, and that just means creating something that you're going to need. So I know I'm going to need an is palindrome checker. So I'm just going to go is pal. That's going to take in some numeric value and then return true or false. Depending on if it's a palindrome or not. So right now, I don't want to worry about that implementation detail. I know that it's going to check for a palindrome. Maybe I don't know how to do it right now, but I kind of want to just get my rough algorithm in place here. So I have my product. I'm going to call my isPal function, pass in that product. If my product is a palindrome, so again, isPal will determine if it is or not. Right now, we're not doing that, but eventually we will. I'm going to need to, I guess, based on our game plan, we have our list of pals. We're going to push our product value in there. Great. So list pals is keeping track of all the palindromes we find throughout these for loops. And then, all right, so we push our products. And yeah, so I think this should achieve what we wanted to. We're going to multiply all of our values in a range by all the other values in the range. Find the product, check if it's a palindrome. If it is, we append it to our list. And at the very end, we're going to go through our list and find the max value. So I guess, yeah, let's tackle that part. Tommy, do you have a good way of finding the max value in a list?
Yeah, you should be able to use math.max, and then let's see, I'm trying to think of how the syntax works. Yeah, math.max, and then parentheses with your array inside of it.
Yeah.
And then you would and then you would need to set that equal to you need to set that equal to a new. Yep, there you go.
All right. Yep, sounds great. Should work, I think. All right, so basically we have our list of palindromes. We want to find the maximum and then return maximum. And then what if our list of palindromes is empty? As in we never found a palindrome in our loop.
So let's see. I would say because if you did math max on if you did the max function, the max method on list pals, and there was nothing in there, you'd get an error. So I would say before you even get there, before you hand it off to like lines 41 and 42. Yep. I would say if length is greater than 0. Yeah, there you go.
Great. Good job there. All right, so I think this should handle our case. So we set our max pal equal to 0 because as the question called for, if we don't find a palindrome, just return 0 here. So I think that should do it. We have our list of palindromes. If we have stuff in there, we'll get the max out of there. So I think that looks good. So good job there. I think this, to me, looks pretty good. We're just going to find products, check if it's palindrome, add it to our list, and then find the maximum later. All right, so I think the last thing we need to do is figure out how do we determine if something's a palindrome. So there's many ways to go about this. I think, Tommy, you mentioned a couple of good ideas. Just to save some time here, I'm going to kind of go with my solution here. Just a quick way to do it. Let's just take our number, and I think you mentioned this. We want to convert it to a string. So let's call that string num equals, I should always remember my let. Do you guys remember how to convert a number to a string? Just a quick quiz question.
It should just be yeah, 2 string and then parentheses and then the number that you want to convert.
Yep, you got it. So I'm just gonna slide in like not a trick, but just an easy way to kind of figure out if it's palindrome. So if I have my number, I could actually split that into a list or an array. And then there's this handy dandy method called reverse. So now this, again, this is more language specific. I just kind of know that reverse exists. So I'm just gonna take advantage of it. Again, if you don't happen to know, maybe your language you're doing this in, reverse doesn't exist, or maybe you just don't know the method. There's definitely other ways you can go about this. But I'm just gonna do this, and then I'm gonna join up that list again once we reversed it back into a string. So what this should be doing is taking a number, basically splitting into a list, reversing that list, and then condensing that list back into a string. All right, so I think that should reverse it, and then basically I'm comparing it to the original value. If those equal each other, then I know this is a palindrome, right? Because I flipped the number, and if it's still the same thing as the original value, then I think that should be a palindrome. All right, so let's see what our test case, our sample test case was. If we have n equals 2, our output should be 9,009. So hopefully this gives us the right answer. Let's give it a run. I gotta take out this console log. I don't wanna flood my console. And let's give that a run. And obviously I should be printing out my value. Sorry about that, guys. Let's just call it let's results equal that and console.log results. All right, let me run that again. I got not a number. That's not what we wanted.
I think the last if statement isn't wrapped. I don't know if that matters. Like on 42.
Here. Let me console.log list pals. All right, so I printed out my list, and my list looks pretty good. I think, these are all palindromes. We got, 858, 2002. So I think that's right. I think it might be our max method. Anyone have any ideas here? So I think max might.
I think max takes in
2 inputs, I think. Right.
yeah, numbers as argument on a list.
All right, so yeah, so we might need to, I guess, spread that out. I think this might work. Let's give that a try. All right, so I spread that out. Let me take out my console log here. All right, so good help there, guys. Thanks for the assist there. But yeah, so I just got to spread out the values. So basically, I find the max in all the values that's passed in there. Does that make sense? You guys are familiar with the spread operator?
I'm not familiar with the spread operator. What is that?
So the ... basically will take all the values in the list and kind of just like spread them out, as in take them out of the list and make them individual values. So I kind of just think of it just like it was present a comma separated, I guess, list is the wrong word to use, but just a bunch of separated values that's not in a container.
Okay.
So yeah, so the max method needs a bunch of individual values. It's not going to handle a data structure. So basically the spread operator will give it individual values, and then it'll find the maximum from all the values it gets through that.
Oh,
yeah,
cool.
we got 9,009, which is the correct answer according to our test case. So I think we got a good working solution here. I guess if you want to test this out, let me try it with 3. Just make sure it spits out a palindrome. This might take a little longer because our space is a little larger, but all right, didn't take too long. We got, what is this? 900,000, 6,609. Looks like a palindrome to me. I think that looks pretty good. Yeah, so I think we have solved this problem. Good job, Tommy. Tommy, thanks for volunteering. Definitely appreciate the help there. Hopefully it wasn't
Thank you.
stressful. I think you did a good job in, coming up with a game plan, and then kind of, helping me come up with like a way to get the ranges, and then a good idea on creating a list, and then find the maximum after that. So yeah, so that was our first task, getting to a working solution. Again, hopefully you guys were doing this at home. Hopefully you guys followed along and or had a good idea on how to attack this problem. But yeah, this is definitely a good problem to kind of practice with, and I think we'll see, I guess, why I chose this particular problem as we get further into the lecture. But with that said, I think we've been going for 50 minutes strong, so kind of want to take a quick break here. So I'm going to say let's take a 6-minute break. I've got 9:54, I guess 9:53. Let's get back together at 10 o'clock and continue from there. All right, thanks guys. Zoom recording. Can you guys still see my slides? I want to make sure those don't get in. All right, so continuing on, we did our practice coding challenge. Tommy, great job there. Thanks for volunteering there and going through the problem with me.
Thank you.
Just want to make sure, are there any quick questions that you guys might have about the challenge? We're definitely going to come back to it. So if everything kind of makes sense there, we kind of want to proceed. But if there's any questions, definitely want to handle them. All right, cool. We'll definitely come back to this. So at the end, if there's any questions also, we'll have time for that too. So continuing on, let's go back to our slides. So let's get a quick trivia question here. What's one of Nike's most famous slogans? Anyone know?
Just do it.
Do it.
Tommy's got it. Jarrett's got it too. All right, just do it. All right. So that's Nike's most famous, one of Nike's most famous slogans. So going off of that, I'm going to go to what I feel like your motto or your slogan should be as a software developer. And here we have just do it better. So this kind of thing I want to convey here is it's great that you're able to problem solve and get to a working solution, but usually that's not enough. Usually we need to get to that next step, which is making our solution even better. Whether that means just easier to understand, just doing it maybe in a more efficient way. There's many ways we can go about making our software better, and there's a whole range of things. I'm going to cover on a very specific part of it in this lecture, but there's a whole lot to learn in how to kind of improve our coding solutions. It's a learning process continually. I'm not great at it. Like, there's, again, many ways to go about it. So it's always a thing that you're developing as you get better as a software developer. So here I have the goals of a software developer. Again, very simple. You can probably apply this to any job out there, anything you do. There's two main challenges that you're faced with. One is solving a problem. That's the first thing we need to do, as we talked about when you're doing a coding challenge for an interview. Your first goal should be to get to a working solution, no matter how you do it. But once you get there, this next step that you're going to need to take, especially again to be a successful software developer, is to solve a problem well. And by that just means do it better. Once you get a working solution, to iterate over it, refactor it, find ways to improve upon it. Again, it's a continual process. It's not something that you just snap your fingers and make your code better. Sometimes, especially with large projects, you're gonna go back over the code multiple times. Usually, code reviews, work on it with peers, and kind of just find ways that you can improve your code. So there's three, I guess, main categories that I created here. One is structurally, and that just means better design. And when I say design, I mean coding design. So do you guys have any suggestions on how, what things maybe you guys learned throughout the cohort that impact structure? Like what things you guys can make use of, what tactics or I guess strategies often are used for coding projects?
I think I have an idea, but I'm not sure it's the best example of structure. For us on our final project, we were making our API calls on the back end, and they were just really small, lightweight JSON files. And it just kind of added extra steps when we realized we could just be calling them from React. And it saved us. It didn't speed it up so much, but it sped it up, and it was kind of a trivial change to make. Would that be a good example of structure?
That's a great example, yeah, on a way to improve code. For that, I guess I would put that into the algorithm bucket, how to algorithmically improve solutions, because that's making it more efficient. I guess for structurally, the things that I have in mind are like using functions properly, naming your functions correctly, using classes. When we talk about object-oriented programming, creating class structures that make sense. Also, when you get into like data modeling, just having correct structures and ways to model your data are very important. So let's, yeah, so here's a few items that I kind of have in mind. Again, this is not an exhaustive list. There's so much to it. But yeah, at the top of it, I have code organization. Again, this is, again, creating your classes, using the right methods, even like making your project modular, right? You want to divide it up into files and smaller bits. You don't want to write your entire code in just one code file and kind of just go from there, right? You want to make it sensible. System architecture. Now, this is something you probably won't be dealing with for like a technical interview problem, because this is more for like larger scale projects you have, like your team projects or your personal projects. But you kind of want decide on what's the right architecture for your application. Do you want to have it be a client server model? Does it make more sense to be peer-to-peer? Again, there's many questions you ask here. So these are probably questions you want to deal with ahead of time, but sometimes you create a solution and you realize there might be a better architecture. You gotta change it up. So that's also another way you can improve your code, just changing, I guess, the core architecture if you're able to do so. The third thing I have here is future-proofing. Now, this is something that's really hard to do. It's hard to imagine what your application might be used for in the future or what requirements might change. But you want to develop your software in a scalable manner. So make sure, like, if you currently are using your application with 10 users, can it handle 1,000 users if your needs change in that manner? You want to at least make your code flexible enough where you can change it easily to adapt. You don't want to have to rewrite your entire code base when your requirements change from the future. So again, a lot of this is anticipation. There's no great way to 100% guarantee you're going to know what your application is going to need to do in the future, but you can plan for it based on the way you code up your project. Reliability, this kind of goes back to testing. How fragile is your code? Like if I change one little function, is my code base going to break completely? Like you want to have test cases written. You want to make sure that your code isn't so fragile. Like you don't want to hard code obviously stuff. You want to make it reliable, as in if you change things or add things, you want to make sure you don't break the core functionality. So again, testing there is a key thing that you can add to make your code better. And then something as simple as readability. Again, you guys have gone over this throughout the cohort, so I'm not going to spend too much time on it, but like stuff like commenting your code using common naming conventions, even adding like documentation. Other people might be using your code. So if you have good documentation, that can go a long way in just making your code overall better, both for yourself, like if you come back to your project, just having the documentation there for yourself, but also if other people use it. So that's some ways you can structurally improve your code. Again, this is more just for the developer. Your end user is not going to really care if you've commented your code or if you've created classes or data models. They just want it to work. So structurally, I'm thinking more just developer ways to improve your code. Then we have functionally. So this is more on the user side, the person actually using your application. So this is where user UI UX design comes in. This is a whole nother branch of software development, something I'm very interested in, but there's a lot to it. So obviously I'm not going to go over much detail there, but yeah, just the visual presentation you offer your user. Is your application like pleasing on the eye? Is it cool? Like, I've seen a lot of your personal projects and your group projects. Like you guys have some pretty slick graphics and like, a good input mechanism. So, I think you guys did a great job there. And yeah, the visual presentation definitely impacts how, I guess, how willing users want to use your application versus something else. How intuitive is your interface? Like, can I just jump on your website? I think one of the groups is doing Travi, which is a travel website. Can I just jump on and kind of just understand how to use it, or do I need to read documentation or kind of like fumble my way through it, right? You want to make it very easy for the user to kind of just understand. Error checking, error handling, again, also goes for the user. Like if I type in the wrong value, is my application going to crash, or the website going to freak out, or is it going to be, you know, handle and kind of what I call dummy proofing? Like, you know, I don't know how to use the application really well, but will it still kind of protect me from doing the wrong thing as a user? And then obviously features, you're going to be adding features to existing projects. The more features your application provides, the more functionally it matters to your user. So, you know, what kind of features can you add in the future? What kind of features do you offer? That's just another way to improve your code. So the last bucket I have is algorithmically. It's kind of a mouthful to say, but this is kind of what Tommy was getting at before. You know, he mentioned a way that they improved the performance of their project. So here, just two main buckets. There might, you know, be other things I could drop in here, but overall, when you're trying to make your code more algorithmically better, it's either you're trying to improve your execution speed, which just means how quickly does your program get from point A to B, where point A is like user input and point B is the output that they're looking for. And the next thing is resource optimizations. And you know, the common one here is how much memory are you using, right? So usually the two main criteria are speed and memory. There could be others, like maybe if you're rendering to a screen a lot, you know, you might be using the graphics mechanism a lot. You need to manage that or optimize that output. But overall, let's say most of the time, as a developer, you're trying to make your algorithm faster. Memory is a concern, especially like if you're creating Adobe Photoshop or any like video creating or editing software. Like those are very intensive memory applications. So at that level, you're definitely going to be more mindful of memory and make sure you're not, you know, using up 8 gigs of your client's memory, because they're going to notice that, obviously. But for the most part, speed optimizations are what you're going to be tackling throughout, I guess, your careers. So that's something that we, you know, definitely can benefit from if, you know, through practice and kind of just like understanding how to go about making your code faster, right? So continuing on, so the key focus of this presentation is to be optimization. And there are a few ways I go about optimizing my code. Again, there's many ways to go about it. There's a lot that can be done, but I kind of prioritize and kind of list the most, I guess, common things that I deal with. So assuming that I've created, like, let's say I've solved the problem, like the one we just did, the largest palindrome problem. When I'm going back over it, again, if I have time to go back over it, the first thing I'm going to do actually is look for low-hanging fruit optimizations or improvements. What I mean by this are just like glancing at the code, just like obvious things that stick out, like, hey, this is probably inefficient. I could do this better. And these kinds of optimizations are things where you don't even really need to know what the algorithm is doing. It's just stuff that sticks out like a sore thumb, like, hey, why am I creating 5 different variables if I'm only using one of them, right? So that's kind of, you know, just the easy to spot improvements that potentially can have large gains. So they're easy to fix and have large gains. Like makes sense that should be the first thing you tackle. Moving on from there, we have, I have redundant work and then superfluous work. And redundant work just means, is your algorithm just doing the same computations over and over when it doesn't need to be, right? So spotting those, you do need to kind of get more into the weeds of your algorithm and understand what it's doing. And then you could definitely spot redundant work. And also kind of going off of that, redundant code. Like you don't want to have a code that's kind of bloating up your software if it can be kind of condensed into like a function, for example, or classes, right? We talked about those in the past. As far as like superfluous work, that's similar to redundant work, but also it's just stuff that you're doing with your algorithm that doesn't necessarily need to be done, whether it be like you're doing it ahead of time and you realize you could kind of delay that and do it later if you need to, or maybe you don't need to, and then you can kind of return early and avoid doing that work ahead of time, right? So that'll kind of speed up your algorithm if you can identify cases where you just want to delay work or not to do it at all, right? Another thing that takes a lot of practice is finding common bottlenecks. So I kind of want to ask, do you guys have any ideas what common bottlenecks would be? Like what's typically slow in applications or systems? I think Tommy mentioned one of them earlier.
Like nested loops.
Yeah, so nested loops, for sure. Common advice would be anytime you see nested loops beyond 2 for sure, that there could be improvement there. Yeah, so anything that's being done a lot of times that can be a bottleneck in your application. I think the thing Tommy mentioned was API calls. They were making an API call and they realized they could be doing it maybe a little better way. Yeah, so stuff that's common bottlenecks for most applications, API calls, anything that's external is going to be relatively slow when it comes to execution. Likewise, like database calls. If you're making a lot of database calls, that's going to slow down your application. And there are solutions that you guys can take if you realize that, hey, this database call is slowing down my application. What can I do? Well, maybe you can make it asynchronous, or if you absolutely need to do it, maybe you could cache the data in a server memory, so you don't have to keep calling a database and you kind of update it as you're going. But yeah, again, there's many strategies for fixing bottlenecks. I'm not going to go into those right now. Again, this is be more high level. But yeah, other bottlenecks, writing to screen. Again, displaying stuff is relatively expensive. We've gone and learned React. React, one of the key traits of React is that it doesn't refresh your entire screen. It kind of updates the components, only the bits and pieces that updated, and that saves screen rendering time, right? So if your application is printing out the screen a lot, that can be expensive and definitely can cause slowdowns in your entire application. So that's something to be mindful of. Yeah, so those are some common bottlenecks. Again, these are things you definitely Google, and depending on your application, it might be different bottlenecks you're dealing with. But it's just good to know about them, and it's just once you know about them, you can kind of either improve upon them or kind of find ways to kind of optimize those. Another recommendation, again, this is more for large-scale products. You're not going to be doing this during your coding interview, but there's many code profiling tools out there, and these are tools that basically will go through your entire program and kind of point out where most of the time is being taken. Again, imagine like doing this on your own. Like, again, you're going to be going through your code reviews, but if you have like a 10,000 line application, it's going to be kind of hard to go through all 10,000 lines and kind of spot like, okay, based on my analysis, I think this function is taking a lot of time, right? It's possible, but these code profiling tools make it a lot easier and are much more helpful in terms of like the data they put out. So these are useful for finding coding hotspots. Again, these are things that might not be obvious to you when you're analyzing your code, but then you realize you run the profile and be like, oh, I didn't realize that my is palindrome checker is actually taking a lot of time. Maybe I should spend time improving that if I can. The final thing I've listed are being familiar with common micro optimizations. Again, these are things that will get better with practice. It's not something you just memorize right away. And a lot of these are just like maybe knowing your language specific optimizations. For example, in JavaScript and most languages, doing like string concatenations are relatively slow. So usually there are multiple ways to achieve this, the thing that you're trying to do. So instead of like, let's say I have 5 strings, I want to combine those. Instead of adding those together with the plus operator, it's generally better to use the join method of the string because it allocates fewer intermediate strings for that process. Again, these are micro optimizations. They might not have a huge benefit on their own, but they're good to just adopt into your normal practices of code. So every line of code you write, if they're have just a better way of doing it, for a large application, they can make a difference if you're just being more mindful of optimizations as you code. So yeah, so those are a list of I guess kind of ways I go about it. Solve the easy stuff, then kind of spot the analyze your code, remove like redundant or extra code that you don't have, and then also focus on bottlenecks. Usually bottlenecks are the bulk of your slowdowns, so it's good to go about identifying them and then also handling them as they come. All right, so when we talk more about optimizations, oh, sorry, I don't want to rush through it. Are there any questions about anything I presented here? I know I should definitely pause there. Any thoughts, questions? Got the thumbs up from Tommy, good sign to have. All right, seeing some thumbs up, so I'm gonna continue on. All right, so it's always also good to consider trade-offs when you're optimizing. So it's great to have a super speedy application that does everything you need and gets the result as quickly as you can. But usually you're gonna run into a point where you've made some optimizations and you need to continue on. You could either kind of accept the optimizations you have and you're fine with the speed, but also there still can be other stuff done. So one thing to kind of balance is minor optimizations versus code clarity. Again, the speed of your application is very important, but that's not the only thing that's important. You want your code to be clear because again, you're going to be using it, and if you're working on a team, like they're going to be reading it also. So you don't want to have super confusing code that might have optimized some very minor thing, but you sacrifice like just the understandability of that code. Just a very quick example I could give is, let's say you have whatever algorithm you're trying to solve, and you have a variable, and you keep reusing that variable for different values at different points. That's usually not recommended, right? You want your variable names to be specific and to convey to the coder what that variable is being used for, right? So I don't want to just have a variable name stuff and then use that variable like 5 different times for 5 different values, right? That's going to be confusing. It's going to be hard to track. The reason why that's an optimization is because you're using fewer variables, so it's fewer memory. You want to create the variable multiple times for different use cases. But at that point, the optimization is not going to be worth it, like 99.99% of the time, unless there's a very specific case where you need to make it faster. Then going off of that, unnecessary optimization versus coding bulk. So when I say unnecessary, these are cases where it's possible that this optimization can have a benefit, but the likely use case is not going to come up ever, or it'll be really rare. So at that point, again, it kind of goes to how much code do you want to add? Like, do you want to turn a 5-line function into like a 50-line function just to optimize for a really rare case? Again, it could improve your performance, but at what cost, right? You don't want to make, you don't want to double or whatever, quadruple your coding size for just a very like an optimization that's unnecessary based on your analysis. And then, yeah, I guess the final note I have here is how much return are you actually getting from optimizations you're making? So when we talk about, optimizations, you should also consider yourself, like a resource. I guess your company definitely will think of you as a resource, and you want to question how much is it like worth your developer time to spend on optimizing this one small thing. If it's going to take, let's say, 4 hours of your developer time to increase performance by like 0.1%, is that going to be worth it? I would say in most cases, probably not. You want to use your time more wisely. Obviously, you're going to have a whole range of things you could be doing. So definitely know when to stop. So that's my last point here. Again, I would say most applications out there, you can definitely improve the more time you spend on it. But you're going to get diminishing returns on those improvements. So there's definitely a good cutoff point where your application is good enough. Maybe save future optimization for the future if they become a problem. But don't spend all your time optimizing and just obsess over it. It's good to know that balance of, hey, my application is good enough, I'm going to move on to something else. Hopefully that makes sense. Yeah, again, always weigh the trade-offs. So optimizations are great to implement, but make sure you're implementing them smartly and not compromising other parts of your code when you're making them. All right. So I got this giant graphic of your turn. So as I kind of mentioned before, we're going to return back to the palindrome problem. And now you guys are going to get more interaction here. Hopefully you guys brought your coding caps. So I have an exercise for you guys. So going back to our coding problem, I'm going to ask you guys to find some optimizations with what was implemented. So as you guys maybe realize when we're coding up, there's probably some stuff that we were doing extra or something that could have been better with our solution. So I'm going to give you guys my solution, the basic solution I have. I'm going to link that in the Slack channel. So give me a moment for that. But so I'm going to give you guys the code that already works. So you don't have to look for bugs or try to like fix it. It works. You trust me on that. Let's take around like 15 minutes. I think we're running a little short on time, but around 15 minutes, and just see what optimizations you guys can find. And just some tips, kind of what I brought up before. Look for low-hanging fruit. And these are things that are easy to implement and can give you potentially big gains. And there are a few of those in the problem that we did. I think the next thing to look for are bottlenecks. Where do you think a lot of the execution time for our solution is being spent? And then if you can identify that, how can you improve that even slightly? Like if it's a bottleneck, like any improvement there has a large improvement on your solution. And then the other stuff we talked about, redundant work and unnecessary work. There might be some of that that's in the coding solution. If you can spot those and fix those, that will improve the execution. And then after like the 15, 20 minutes are up, I'm going to ask you guys to submit your optimized solution again if you want to, and then we're going to kind of have a little competition to see who found the most optimizations or who sped up the application the most. So hopefully you guys enjoy that. Let me throw in the link in the Slack channel, and that's how it works. One thing I want to mention, so if you guys are not familiar with console.time, this is a pre-built, sorry, I should mention, we're going to be coding this in JavaScript. So console.time, it basically starts a timer for you, and you make any function calls that you want in between, and then call time.end with the same timer name, and this will basically output how long that function call took. So it's a useful profiling tool. It's not super reliable, but it'll give you a good metric of how long your function call is taking. And you use this time metric to kind of see how your improvements, how your optimizations are improving your algorithm. Again, your outputs might kind of vary. Like if you run the same function twice, might vary by like 10 milliseconds. That's kind of to be expected. So don't rely too much on the number, but kind of see the improvement as you go on. So let me throw the thing in the mic channel. Give me a moment. Sorry about that. Are there any questions on what I'm going to have you guys be doing with this exercise? All right, so let me throw in the source. I'm going to be putting this in the mics channel. All right, so it's a Google Share Drive. You should be able to grab the file from there. And if you guys have any trouble, just let me know. But hopefully it should be public. And yeah, so there's a file in there called, I believe it's largest palindrome _ your name. Directions I have for you guys are grab that file, put it on your machine, rename the your name part with your actual name. First name should be fine. We might have some students that have duplicate names here. If so, just add a last initial. But yeah, just replace the your name part in the file name. Also, there's a variable in there called name at the top. If you could just add in your name there, it would help me identify you guys when I'm running your solutions. The only request I have is do not change the signature of get largest palindrome function. You could add any other functions you want or change other functions that may exist in there. But otherwise, your task for the next, I guess, let's say 15 minutes is to optimize. Find any optimizations you can. There are a number of them that can be made. So I'm going to say good luck with that. Again, if there's any questions, I'm going to be on the call, so just ask. I'm going to pause the recording, so it won't be an empty stare for 20 minutes. But let me know if you guys have any trouble grabbing that file. And I'm going to post a link for submitting shortly. Too much of, I guess, brain stress on you guys. But again, this is kind of how I go about optimizing code. Again, this is a particular example, but hopefully some of the items I mentioned here kind of make sense. Again, avoiding expensive work, kind of if you're doing something a repeated amount of times in for loops, extracting that out if you can, and kind of just being mindful of what you're searching for. Again, in this case, we're looking for largest, so it makes sense to use the larger values first rather than smaller values. And then, yeah, if you can find like special cases, like again, the I mod 10, again, this is a very special case for our needs. Just trying to find those special cases cuts down on the work that you guys have to do. All right, we're hitting 11 o'clock, so I definitely want to wrap this up. I appreciate you guys spending time with me. Any quick questions on optimizations? Again, I'll be available after this if you guys have further questions. But does that kind of make sense how to go about maybe adding more optimizations to this particular problem?
Sorry. I was gonna say in interviews, often are you really just kind of going over like how you would optimize more than actually like trying to code out some of the optimizations?
So I'm glad you asked that. So tying back to interviews, depending on where you're interviewing, stuff like this could be very common. I will say my background is from a financial trading firm, and I know some of you guys might be interviewing with CTC or DRW. Again, optimizations are key for their business because for the trading world, every millisecond gain you can get, that means money in your traders' pockets potentially. So yeah, don't be surprised to see optimization problems. Again, if you're doing coding challenges, they're going to be testing you, if you can solve the problem, but also if you can find small optimizations. Again, given this interview problem to when I've done it before, like we don't expect everyone to find all the optimizations right away, but we definitely want them to find some of the easier ones and want them to be able to understand, when we go over the problem, why we're making certain optimizations. But again, it's all about being mindful about improving your code. Like again, the goal here isn't to know how to optimize every problem you're given. It's more about having that mindset of, hey, how can I make this better? What are the steps I can take to kind of identify the process of finding optimizations I can make? All right. Cool. Was there any other question?
Would you mind posting your the optimized solution? So we can
Absolutely.
look at that?
Yeah. I'll post more in the chat afterwards. But yeah, thanks for your submissions. Hope you guys kind of enjoyed that exercise. If not, I apologize. But continuing on, all right, we reviewed some of our optimizations. Definitely can go over with you guys more after the presentation. All right, so just to summarize here, key takeaways. The number one takeaway I want you guys to have, which I kind of just mentioned, is have that mindset. Again, it's going to take practice to become a better like optimizer and all the other changes we talked about, like functionally, structurally, and algorithmically. But just have that mindset. Even if you're not there where you can like implement them, know that, look for the ways you can improve your code and kind of think about it like, hey, don't just settle for, hey, this works, I'm good, right? Have that extra step. And I think that'll go a long way in your careers, just becoming a better software developer. As I mentioned, we went over some optimization techniques and some like cases you come up with. Again, this is more about practice. You'll get familiar with finding optimizations and applying them the more and more you do it. So it's a process. It's not just like, hey, I know it now. You're always learning, always finding better ways to do stuff. So yeah, kind of, again, adopt that and kind of practice it through your normal coding. Just be mindful of like, hey, I'm doing this one way. Is there a better way to do it? The last takeaway I'll leave you guys with is don't get stuck over optimizing. Again, every piece of code you have can probably be made better slightly or different ways, but make sure you're weighing the trade-offs. Like, do I need to be doing this? How much of my time is gonna be spent doing this? What are the gains versus the trade-offs with like coding quality and coding bulk? Were there any questions that I can answer? Again, I'll be available after the presentation. I know we have a lot to get to today. You guys have a busy schedule ahead, so definitely want to take some questions if you guys have it. Otherwise, can answer them later too. All right, got the thumbs up from Frankie. All right, thanks. Again, post any questions to me on the Slack channel, and I'll be happy to answer them. The final thing I want to leave you guys with is thank you, a thank you, a thank you. First, for your service to our country. It's probably the only chance I get to kind of speak to all you guys. I guess some of you guys aren't here, but totally appreciate what you guys do for our country, you and your families, a lot of sacrifice, a lot of respect for you guys. So I just want to make sure I said that to you guys if I hadn't already. Second, thank you for welcoming me. You guys have been great, allowing me to observe your cohort as I kind of get familiar with the process. So again, you guys have taught me a lot just based on letting me observe your lectures. Your presentation has been awesome. Again, you guys have been great. I'm saying this honestly, I feel like you guys have set a high bar for the next cohort that I'm going to be dealing with. You guys ask great questions. Your personal projects, team projects look awesome. So yeah, you guys have set that bar really high for the next cohort. So I have a lot of expectations based on what I've seen from you guys. And yeah, again, thanks for taking the time sitting in on this presentation. I know I ran kind of long and you guys have a busy schedule, but I appreciate you guys sticking with me here. But yeah, thanks a lot for that. If you guys have any feedback for me, I'd greatly appreciate it. I'm going to post a form in the Slack channel. Again, totally optional, will be anonymous. But if you guys have any comments, again, I'm kind of new to this. So if you have any feedback, especially anything critical, if anything I didn't do well that I can improve upon, would love to hear from you guys. But again, totally optional, no pressure there. We'll only take a couple minutes if you guys want to do it. Last message, I promise, last slide here. Good luck with everything in your future. Again, you guys have interviews next week. Hope you guys do great with them. Definitely, if I can be a resource in the future at any point, hopefully you guys will feel free to contact me. And yeah, I hope you guys have a successful software development career ahead if that's what you choose to do. But best wishes for that. And again, thanks a lot for everything. And that wraps it up.
Awesome.